Okay, welcome to section 3.6, Universal Asynchronous Receivers Transmitters, also known as UARTs. I'm Dr. Piccone. I wrote a book with Drs. Garbini and Devine on real-time computing. Check it out at the MIT Press website or at the companion website, rtcbook.org. Okay, UARTs, or UARTs. They are hardware devices that allow a computer to asynchronously and serially communicate with peripheral devices. A UART uses local logic levels, usually CMOS, whereas peripheral devices sometimes use other signal levels, such as those corresponding to RS-232. In those cases, a level converter lies between a UART and a peripheral device. Often a UART is also present in the peripheral device for reconstruction of the parallel data that has been serialized. A typical UART is capable of full duplex communication, meaning that it can send and receive information at the same time. A UART can be purchased as an integrated circuit, but it typically comes integrated with most real-time single-board computers, microcontrollers, and systems on a chip. The general operation of digital circuits will be addressed in Chapter 5, but the high-level operation of a UART is explained in this section. We don't necessarily need to know the details of the digital circuitry. Shift registers. The key elements of a UART are digital logic circuits called shift registers. The term register is used in the usual sense here, a small, usually 4 or 8-bit local memory. The term shift refers to the ability to move its stored bits, typically left to right. There are two common configurations: parallel in, serial out, which can load the register all at once and release its values serially by shifting rightward. This is what allows a UART to convert parallel signals to serial. Okay, parallel in, load the register all at once, and then serially dole them out. Conversely, serial in, parallel out loads the register from the left, shifting bits rightward as it loads, and finally releases the loaded bits to a parallel signal. So, in one at a time, out all at once. Shifts typically occur at regular intervals determined by a clock input, which is just another digital signal that pulses high-low at regular intervals. The state at the outputs during loading and shifting can be latched, i.e. static, or not, depending on the model of shift register. There are many varieties of shift register, but those in a UART are typically of the PISO or SIPO type. The function of a UART. A UART functions as an interface between a processor's I/O bus and the pinout, the input and output pins to which peripheral devices can be connected. Depending on the internal logic levels used by a UART and processor, and the logic levels used by a given peripheral device, there is often a need for a logic level converter between the UART and the pinout as shown in the figure. So in the figure, we have the processor on the left, we have the UART in the middle with its two shift registers, one PISO and the other SIPO, and a logic level converter between the UART and the peripheral device, which is on the right. The primary internal function of the UART is that of a pair of shift registers, one PISO for converting parallel signals to serial, and one SIPO for serial to parallel. The PISO is used for outgoing processor to pinout signals, and the SIPO is used for incoming pinout to processor signals. Something not shown explicitly in the figure is timing. A UART can typically be configured by the processor to have a specific baud rate for shift register shifts and I/O. A UART can transmit and receive data with different baud rates, parity bits, stop bits, and other settings. Therefore, it must be configured to communicate with a peripheral device. It must match the settings of that peripheral device. So inside the UART, we have this parallel signal coming into the output shift register, which is a parallel in serial out. And then when these outputs are sent serially, the bits are shifted rightward, and one at a time, the levels are asserted to the serial out, potentially through a logic converter, if necessary, and to an output pin. Conversely, for input serial data, it would go through the logic converter if necessary, then shift bits leftward until the register is full, then release all of the parallel inputs to the processor at once. Okay, so that's the basic function of a UART at the hardware level, at a very high level, but that gives us enough understanding to know how to configure one so that it will work for us in the lab. Okay, we'll see you next time.